Dear participants of GRID conference, my name is Iskren Spiridonov, and I'm going to present you the paper Evaluation of the Influence of Artificial UV Aging of Printed Images. The main goals of this research are to investigate the influence of artificial UV aging on optical density, spectral and color characteristics of printed images. This research is part of few papers of authors. This is one series exploring the processes of aging of images and aging of materials. We have done mathematical modeling of the aging processes of the materials and images, depending of the following few parameters. This is aging time, temperature of aging, irradiation with UV light, type of material, type of inks, and coatings. The proposed approach for the complex study of the influence of aging process on the image and materials includes the following indicators. The first indicator is changes in color characteristics expressed by LAB or LCH color system. The second is color differences during different periods of aging, changes in color gamuts, shapes and volumes, changes in optical density, and changes in tone values during the aging process. The using of these proposed methods and application of the obtained from the series of researches mathematical models leads to restoration of the original colors of works of art, paintings, icons, printings, books, and many applications could be found. The main goal of experiment is creation of the adequate model that can very precisely return the original colors of the studied object before aging. Now you can see the detailed plan of the goals of experiment on your screen. We have created two test forms which are used for the experiment. Each of these test forms contains different color patches, control elements, images, and many more elements. We have chose two commonly used papers in this experiment. The first paper is uncoated offset paper, and the second paper is matte coated paper. We have made few analysis of these papers before we use them, and after that we print these test forms with offset printing method on these two papers. So we have made artificial UV aging with QSUN xenon test camera, and that is the important that the measurements were done on intervals starting of course from 0, 6 hours, 12 hours, 24 hours, and up to 200 hours irradiation with UV light. We have made spectrophotometrical measurements and densitometrical measurements, so with different devices, of course. Some of the color measurements were made by hand, the other were made automatically with X-Rite I1, I0, and we have collect enormous data from color measurements. Of course, we print the test run with defined, predefined optimal inking. We have defined optimal inking for these two papers, matte and offset paper. You can see the values of optimal inking that we defined before the experiment. And after that, for the purpose of experiment, we have selected different tone values from the CMYK colors. We have selected tone values from the dark tones. This is 100%, mid tones 40%, and white tones we have selected 7% of tone value. On figure 1 and figure 2 you can see the influence of artificial UV aging on the optical density of coated and figure 2 of uncoated offset paper. You can see the changes in density for all four colors CMYK in dark tones, mid tones and white tones. So we have established a big decrease in optical density, especially in yellow color. You can see that the difference in density is about 0.67 units of density. This is a very big decrease. So we have made conclusions for all four colors, for all range of tones. Now you are seeing the figure 2. This is the influence of UV edging for uncoated offset paper. The results are the same. And now in these two tables, table 2 and table 3, you can see the differences in optical density on both papers in the white, middle and dark tones. You can see that especially in magenta and yellow there is a very big difference, and the optical density for both papers is changed in following order. The first of course is yellow, after then the second biggest changes are in magenta, after that in cyan, and after that in black. On table 4 and table 5 you can see the differences in color coordinates expressed by LAB and LCH. We have made measurements, of course, and calculations in two color systems because some of the results can be interpreted better in LCH color system. You can see the changes. Now you are see the rest of the data. In color data, in changes, we have calculated the color differences. You can see how much and how big are color differences, how much and how big are chroma differences and hue differences. And the conclusions are that after performing of artificial UV aging of 200 hours of irradiation, it was found that the greatest changes occurred in the saturation color coordinate for the matte paper, reaching values of difference in chroma about 50 points. This is very big differences. And we observed 2 times larger differences for matte paper compared with uncoated offset paper. You can see for offset papers the differences in chroma coordinate is about 25 units. This again is very seriously, but in matte paper, of course, there is logically the difference in chroma is biggest. There is a significant change in color tone hue coordinate for coated matte paper, reaching differences in hue coordinate about 16, 17 points, and for uncoated offset paper the differences is up to 11, 12 points. In the process of UV irradiation for both type of papers, there was almost no change in whiteness coordinate of selected fields except for magenta ink. For matte paper, the differences in whiteness coordinate is about 10 units, and for offset is about 4.36 units. The second conclusion is that after all this period of irradiation, it was found that the optical density became smaller with increasing of time of UV aging. In some cases, in the white and medium tones of 7 and 40% in yellow fields, we observed vanishing of the raster elements, especially in the yellow. And the third conclusion is there is observed that the same for both paper optical density changes in white tones and medium tones. The change in optical density is almost the same, but for matte coated paper the values being slightly higher. For dark tones it is evident that for the matte coated paper occurs 3 times more changes in density than for offset uncoated paper. Thank you for your attention.